I'm Patrick. Lee introduced me. I've been leading this Pass the Hash initiative here at Microsoft for the last few months, and what I'm going to be presenting today is most of the work we've done that has been published in a paper last Tuesday. We're going to cover a few things here that are also available in that paper that you can read, and basically it's just a summary of that. So we're going to talk briefly about the problem. Mark here has been done some work with our work group as well, and he's going to cover a few things and do a demo for us on Pass the Hash. I'll cover the attack scenario, and then we're going to jump into the mitigations. We came up with a few mitigations that can be done today. They're easily implemented, broadly applicable, and then I'll close it off with the white paper itself, a link to it, and what our next steps is. So, Mark.
All right, how many people are familiar with Pass the Hash and the problems that it causes? How many people have worked at gone to a company that's been breached, and you've seen that the attackers made their way through the network using Pass the Hash as a way to get around? Anybody? Nobody? I can't see anybody raising their hands. I guess a few people.
Super secure.
All right, so Pass the Hash is actually a really hot topic. It's been one. Pass the Hash was a type of attack that has been discussed for probably over a decade, but it became really popular about 4 years ago when a person named Hector Ochoa wrote a little tool called Pass the Hash Toolkit that enabled attackers and penetration testers to easily carry out Pass the Hash attacks against Windows. Now, the Pass the Hash attack isn't something that's unique to Windows. It's the attack leverages cached credentials on a system that the attacker has breached and uses those cached credentials then to authenticate to other resources on the network, whether they're other servers or file shares or even interactive logons to other systems. The hashes are actually cached on the system as a convenience to the users of those systems. A typical user will log on to a workstation at their office, and then they'll go and access network resources, their file shares, the SharePoint sites, and what's happening under the hood is there's authentication happening to verify that they are a user that has access to the particular resources that they're trying to touch. That authentication process in most cases is completely transparent to those users, and on purpose, because if the hashes weren't cached, then what the user would experience is a pop-up saying, please enter your username and password every time they hit a new resource on the network. And so somebody that's interacting with a lot of different resources would be consistently or constantly having to enter their credentials, and we call what they experience at that point credential fatigue. So caching the credentials, it enables the single sign-on experience that everybody knows and loves, where I can just go access the share, and underneath the hood there's verification that I am who I am, and I can access the share. So Pass the Hash then takes those credentials, and the attacker then goes around and accesses those resources as if they were the user. And this enables them to spread throughout a network. If they compromise a machine, and they have to have admin access in the machine to get access to those hashes because they're stored in an administrator-only accessible part of the system. But once they've got those hashes, then they go and access another system. And if those hashes are for an account that gives them admin access on that other system, then now they've got admin access on that second system and then can harvest credentials from that system as well, including the cached hashes from whoever else happens to be logged onto that system at the time they breach it. So in this way, and Patrick's going to talk a little bit more with a flowchart of the attack scenario, but this particular use of credentials, both to move around the network as well as to elevate privileges once you're on a system and you happen to find somebody else logged on that is even more privileged than the original hash that you captured, is the technique that's most commonly used by attackers and malware to spread throughout networks. And so our customers are constantly running into problems where their systems are breached at one point in the system, and then Pass the Hash is used for the attacker to end up owning the whole system. And if they come across a very privileged account, then they end up owning the whole domain, and it's game over, and it's a massive cleanup job for them, and we come in and try to help them clean up the mess at that point, where every resource on the system is potentially compromised. So top of mind for us is helping customers figure out how to prevent those kinds of attacks, how to protect the high privileged servers as well as the high privileged users in those kinds of environments. And that's what Patrick's going to focus the latter half of the talk on, which is this Pass the Hash working group that we formed within Microsoft to say, what are all the mechanisms, the tools, the policies, best practices that we've got that we can share with customers for how to stop attackers from owning your whole network just because they managed to breach one single system. And now I'm going to go ahead and turn it over to Patrick. He's going to walk through the attack scenario, and then I'll come back and I'll show you actually what this most recent incarnation of the Pass the Hash toolkit and the Pass the Hash attack.
So I'm going to frame the attack scenario with lateral movement and privilege escalation. When we look at the attack, we assume that there's a certain number of compromised machines on the infrastructure, right? I mean, all organizations have to assume that these days. I mean, that doesn't justify not having preventive measures, but we know that there's a certain amount of computers compromised. So if we introduce that compromised machine to the environment, or we compromise a machine that's already within that networked environment, there's going to be credentials or secrets within that memory and storage on the machine. If those credentials are extracted from either process memory or storage, they're able to perform either lateral movement or privilege escalation the way we're going to look at. And by lateral movement, I mean if the computers that are further compromised after the initial attack are within the same trust value to the organization, we consider those lateral movements. I mean, for an example, a desktop or an end-user workstation gets compromised, and the computer has, or the image that was used to deploy those computers share the same username and password. Obviously, they'll be able to retrieve and use those just like plain text password across the network and compromise the other machine. Now, the level of compromise that's required for the initial attack is that you need local admin or system access, or being able to install drivers and debug programs. So there's a significant amount of privileges that are required on the initial attack, but obviously this is pretty easy to obtain and has been proven to be a really successful attack. If, for an example, for the purpose of this example, if the computer is compromised and secrets are retrieved from memory, the attacker will look at those secrets and try to compromise further computers. So say, for an example, that he's able to perform lateral movement within that environment. All of a sudden, the attack surface is greatly expanded because you have access to a bunch of other machines. And if you have the same level of privilege of the initial computer that you compromised, say local admin account, then you can retrieve the secrets from these computers as well, increasing the attack surface significantly, right? If one of those credentials are privileged when this occurs, the attacker will be able to use those credentials to access to privileged services or servers. And that is what we consider privilege escalation. If one of those accounts allows the attacker to further, say the attacker was able to compromise the server environment, and again, same image was deployed, the level of access allows for the attacker to compromise further hashes and passwords and secrets from memory or from disk or from registry, then they'll be able to perform, say, lateral movement within the environment. Now, at that point, there's been a significant breach in the organization. So it's a matter of time for the attacker to obtain really complete control of the environment, because the attack surface has increased to a point where those servers, the secrets that are going to be contained within that, are going to be obviously a lot more privileged than you should be able to find on a workstation. But it has been proven that a lot of our customers still use practices that allows for high privileged secrets to be exposed on end user machines, or privileged domain accounts that are used to manage servers, or other scenarios where those secrets are exposed. Now, if one of those servers, for an example, contains an administrator account, whether it was used for administrator or some other task, obviously there's a complete compromise of the environment. We're all familiar with privilege escalation and lateral movement, but I think if we frame it this way, when I get down to the mitigations, it'll make more sense for all you guys. So then Mark will do a quick demo of the tools and actions that, and then we'll get back to talk about the mitigations themselves.
The machine that I've got in front of us is a virtual machine that's part of a domain that I set up. This is a member workstation in that domain. And I'm currently logged into this workstation, who am I, as the domain administrator, mrdomain/administrator. So this is actually representing the worst possible best practice. I guess you call this the worst practice, which is a domain admin logging in to a member workstation on the domain. domain admins should be logging into nothing except for the domain controllers. In this case, this is an extreme example of privilege escalation that I'm about to show you. A more common example, though, and one that many companies are susceptible to, is help desk. Help desk users, which have local admin privilege on all the member workstations in the system, in the network, and possibly even servers in the system. And they log into a member workstation, and then they've exposed the keys to the whole kingdom with their cached credentials while they're on the box. Actually, we were told by the US government we're going through auditing to get certain certifications in our cloud services, and we've talked to the government auditors, and one of the attacks that they see have actually seen perpetrated on government organizations is that an attacker gets into, for example, a secretary's machine, they breach that, and then they have a piece of malware that's on the machine that actually induces slow system performance or weird errors. And the secretary then calls up the help desk and says, I've got a problem with my system. The help desk then logs in remotely, and at that point, the credentials to the network are compromised. So in this case, like I said, it's the domain admin. And the tool that I'm going to use is something called Windows Credential Editor. It's, like I said, it's by Hector Ochoa. He works at a company. If you search for Windows Credential Editor, you'll go find where you can download the 32-bit and 64-bit versions of this tool. And what I'm going to do with this tool first is set up past the Kerberos ticket attack. So what I've just done is dumped the Kerberos tickets for this logged-in administrator, domain administrator, into a file on the system. At this point, I'm going to switch user and over to a local user, a local admin. And this local admin is going to represent, actually, I don't want this to be maximized, so I can do a Control-Alt-Delete. And so you can see I've got Abby Local logged on. Abby Local is a local administrator and represents the compromised account on this machine. I've got Windows Credential Editor running here, and if you type it without any parameters at all, what it dumps is the NTLM hashes of the accounts currently logged in the machine. And you can see one of them is Abby's local NTLM hash. So this is the hash of Abby Local's password, and here's the hash of the domain administrator's password, which has been cached so that they can perform NT-LAN manager authentication to remote resources. I'm going to pipe that into a file to make it easier to copy out of it. And then I'm going to use a feature of the tool which lets you take a cached hash that's dumped out in this form and inject it into another login session. So this will be injecting the admin account's hash. And I should have shown you this before, but I'm going to trust me that this wouldn't have worked a second ago. This is the admin share on the domain controller, MRWSK2x64. And because I've dumped, because I'm now leveraging the domain admin's password, I'm going to be able to successfully authenticate to that share. And that should just come up in a second. Whoops, not found. WS2K8. And that then comes up. Now what I'm going to do is demonstrate the second type of attack, which is to pass the Kerberos ticket attack, by logging out of both of these accounts. So basically resetting, logging back in as the domain admin, and then logging that account out. And so at this point, there's no cached credentials on the machine. I'm going to log back in as the Abby local. And instead of leveraging the NTLM hashes, which aren't in memory anymore, I'm going to leverage the Kerberos tickets, which have a lifetime by default of 10 hours. So for up to 10 hours, this type of attack will work, and would work by me taking these two files right here, and I can reuse them from this machine, or I can actually copy them to another machine and use them from there. So this is another form of lateral movement using the Kerberos tickets called pass the ticket. And at this point, I can do, let me show you that I can't access that. admin share any longer. So I get the expected error. Now I'm going to inject those tickets into my session with the dash lowercase k. So I've just injected the admin's Kerberos ticket into this login session. And now at that point, I can authenticate as the admin to that admin share. And so I've then passed that ticket to move around the network in that way.
So we often get asked by our customers, why can't we just release a patch and fix this? I mean, I think most of you that work on the consulting side of things often hear, like, is there going to be a fix for this? As Mark pointed out at the beginning when he was talking about a problem, this has been one of the top priorities for some of our customers. So we can't just fix it. There is no fix for handing over your privileged accounts, whether that is through pass the hash or other credential theft and reuse. If you go out and you release those credentials, as soon as you authenticate to a machine that could be potentially compromised, you're basically handing over that trust for that account. So there is no way to apply currently, at least, a way to fix this immediately. That doesn't mean that we're looking, that we are not looking. We're still always exploring ways to enforce the platform. Throughout this process on the work group, we've met extensively with the Windows product group, and we looked at things, what can we actually do on this that is, that could also, provide a significant amount of resilience against these attacks. There's no immediate fix for it, but there's things that can be done. And it's interesting that when we looked at what can be done, we actually fell back to the basics. We were looking for things that are significantly less impressive in terms of by not disclosing those credentials. But we also have to keep in mind that this is available because of SSO, right? Single sign-on. There's a requirement there. I mean, if we disable all those credentials from being in memory or being anywhere, the user would have to enter those credentials a number of times. That would make the system completely unusable. Or, I mean, for some, maybe it would be usable. But if you need to access network resources or you need to access your email, obviously that hash, those secrets are being used underneath by the operating system to perform actions on behalf of the user. So what can we do? I mean, we need SSO for system usability. We need to protect those secrets. I mean, at this point, we have a few things that can be done. Those secrets, by the way, there's possibly more, but usually NT-hash and LM hash is also available in memory. Kerberos tickets can be reused, just like Mark demonstrated, and there's a number of places where they're stored, whether it's Active Directory or the local system itself. Logon password verifiers are non-exploitable. They can be brute force, but we do provide some sort of resilience on that, and they're salted. However, it's still, if you upload to the cloud or there's a botnet, it's still perfectly, but they're not usable for pass the hash or reuse on that form. So we get asked that often, so I thought I'd point that out. So the mitigations. There are 3 basic mitigations, a little bit overloaded because they got a number of tasks that needs to be done. But like I said, we fell back to the basics. We need to protect those privileged accounts. We have to figure out a way that they're not exposed, yet we still need to provide the means for those administrators to do the tasks that they need to do without exposing those credentials. Mitigation 2, we need to protect those local admin accounts because you need to be a local administrator to continue to dump the hashes and secrets or other privileged accounts. But usually the challenge is because on most computers, the domain account that is used to authenticate is usually enrolled in the local administrators group, right? So obtaining a local administrator on a machine is not really that challenging. There are ways we can protect those local administrators' accounts from being exploited. Also, local administrators' account has been, or at least the built-in, has been disabled by default, but obviously your customers still need it because they continue to re-enable, and it's extensively used in the deployment of images and automation, and we've heard them on that, and that's what this mitigation is all about, mitigation 2. And mitigation 3, as a requirement, you also need to be able to reach those computers. So at this point, what we can do is we can use the Windows firewall to restrict it. And again, these mitigations are basic. They're basic things that can be done right now. And I recall even talking to some of our consultants that were like, wow, these are pretty simple. And I'm like, well, are they even using these? And we found that a lot of the cases, they're neglected or not used, and that's why, they should be a first step. Even if the environment was hardened, there's still practices that need to be done. There are things that can be done to facilitate those accounts and or those mitigations, and that's what I'm going to be talking about on the next step. So for mitigation 1, we want to restrict those domain administrators and enterprise administrator account from logging into the computer or computers of lower trust. That can be done to group policy in the white paper that we've published. If you guys need details, there's step-by-step things that you can do from settings all the way out. If you don't know exactly what we're doing, we have created a mechanism to facilitate that. If we restrict the domains and enterprise administrators account from accessing, they need to have the means to do that, right? They need to have, if they go and we do all this of restricting and yet we don't provide them a way to securely access, if they enter those credentials on, say, a computer of lower security level, those credentials could still be exposed. So we want to provide a way or a secure platform that those administrators can perform their administrative actions. We want to make sure that those accounts are marked as sensitive and that cannot be delegated, so they can't be impersonated on behalf of the user. And we want to make sure that services, they're not scheduled to use those accounts. We found often that there are services that don't need that level of privilege, but often they're set up with privileged accounts just so they can get it working, and usually they're never revisited and they remain that way. So protecting those accounts, we can use group policy to enforce where they can be used to log on. But there's obviously a number of steps. They're simple mitigations, but they need an extensive thinking process and a planning process in order to be able to deploy them effectively if the environment already used those practices for everything. On mitigation 2, local privilege accounts, especially the built-in local administrator account, has been disabled. Like I said, if customers are re-enabling, if the local administrator account is disabled by default, this mitigation doesn't need to be applied. And also, since Windows Vista, we have the token filter policy, which allows, if a local administrator account is compromised on one computer, those privileges do not carry it over. And one of the steps that we're doing here is enforcing that if they have operating systems that support that, Vista and above, to reinforce that policy is still a default policy. Expliciting deny network logon for those accounts. So through the attack scenario, credentials are usually captured or stored on an interactive process. They're stored in memory or they're stored but the way they're used is usually through network logon. So that's the process or the mechanism that SSO works. And there is policy to deny network logon for those accounts. So even if they do need those accounts for whatever business processes that they require, our customers could still disable using deny network logon for those accounts. Now, the last step, and this, I mean, usually in domain accounts, we don't see accounts, or at least if from a different user, it's unlikely that the password is going to be the same. But obviously, local admin accounts, they're deployed through image, they usually have the same password. And so as a last step on this mitigation is to make sure that those local accounts do not have the same password. It's a challenging thing for some of our customers to administer. There's tools out there that are set out to do, and we have provided some scripts and some mechanisms in our white paper to address that. Now, these mitigations, ultimately, they would protect this initial, or the ability for the attacker to obtain those privileged credentials and carry out. But that doesn't justify, and that's why we put them in this order, that those privileged credentials should still be in memory. And at last, for our simple mitigations, it'd be to make sure that access to those machines may not be required, and we can use the firewall to determine which inbound connections are trusted or not. And that's seldom used. I mean, if you have a segmented network, obviously it becomes a lot easier because you can do by pool. But what we were encouraging here is that from a workstation perspective, because from a server environment it might also be challenging, even though not all servers will require file sharing and sharing as a service. So what we're proposing here is to restrict those computers, at least inbound connections, from trusted. So from the pool of servers that are providing services to those machines, and from, say, help desk functions or other functions that need to authenticate. And the whole purpose of this mitigation is to really focus on the initial lateral movement that's compromised at the lower trust level. Now, this doesn't really address at a server level because some of those servers are not going to be able to use this mitigation, but it provides a significant more resilient mitigation in terms of preventing lateral movement. we took these mitigations and we put them in an assessment perspective and start thinking, well, how much effort would it be required to implement mitigation 1? Now, these are perceived effort from our groups, from MCS or Microsoft Consulting Service, from MSIT, from TWC. There's a number of people that participated in this work group. And we felt that it would be a medium level, give or take, for those. And they would provide excellent, as an excellent mitigation 1, to prevent privilege escalation. And obviously, if those credentials are not there, they can be harvested and reused. For mitigation 2, if we're focusing on lateral movement, again, same thing. It's a good mitigation. Even if you capture the hashes, you can't use it or any of those secrets, because deny network logon for hashes, it's not, or for the account itself, it's not going to allow. Even if you have the secret and they match, you still can't use it. And at last, I mean, the password being unique to those accounts obviously prevent those accounts from being reused. Because as a requirement, the credential have to exist in the machine, and you also have to be able to reach the machine and being able to authenticate to it. So the last mitigation, restricting inbound, even if all else fails, the machine can only still be accessed from trusted sources. So this is, we came up with this. It's more of a summary of the initial part of our white paper, and then we started looking, okay, what else can we do? Because there's other recommendations that can be done. There's a number of things that can be done. We got asked, well, how can we didn't consider this? Why didn't we look at IPsec? Why didn't we look at a number of other mitigations? And we were looking for things that were broadly applicable. But there's other things. And I mean, our work is not done. These were first steps. We felt that those 3 core mitigations were the most robust, broadly applicable to different domain configurations, and that could be easily or fairly easily applied, and did not have a really high effort required to be able to be implemented. Removing, and then we came out with a second section of our investigation that was like, okay, what about all these other things that we can do? And again, this is by no means a comprehensive list. There's a number of other things that can be done in terms of recommendation, and we will be looking at it at some point. Now, removing users from the local administrators group came up as a recommendation. Well, can we do this? Because obviously that access is required. Again, even if that particular user is compromised, it would still be contained within the context of the user. Lateral movement and escalation would not be possible. But we felt that the requirements to be able to implement this recommendation is fairly high. I mean, business would have to change the way they do process, and they allow their users to install and deploy applications. And again, it's a pretty common practice to have the local the domain user for a particular machine to be enrolled in the local administrators group. So it's a challenging task, but that would prevent privilege escalation. Limiting the number of domain admins, this was one of the recommendations that came from most of our consultants and even some of our MSIT, that we have a lot of local administrators, and they usually find organizations with a lot of domain administrator accounts, a lot of privilege accounts that do not have a life cycle, they do not have a mechanism for maintenance. So we have provided that as a recommendation, and we rate these are good because you can have all these recommendations but still be exploited. Right? Pass the hash and credential theft and reuse is still possible in a fully patched and fully secured environment. But these recommendations, they do reduce the threat that our organization is. Usually we find them all together. If an organization cares about some of these recommendations, they usually take it a step further, and they're asking us for things like mitigation 1 and 2 and 3. But if they don't, we find a lot of privilege accounts, they're all over the place, and that kind of thing. The last one goes without saying that obviously you can do all this, but if the domain administrators are using to receive email and doing all sorts of other user activities on those accounts, there is no, it would be a significant risk to privilege escalation of the domain accounts. Outbound proxy, we covered that because we felt a lot of organizations use it. It supports authentication, so it's a really easy setting to prevent those local administrator or those domain administrators to be handed over off the organization. So it's a fairly easy and easily applicable recommendation. Question came up quite a number of times about, well, you don't want these privileged accounts to be on, or you're recommending not to use them to do certain administrators. So how can you do some of the support functions and among other things? So we recommend them to use management tools that do not place those credentials. They are available. Some of them use screenshots. Some of them use different mechanisms that do not quite require the same authentication that we use, for an example, on RDP, which is a concern. And also, the fact that if you have a compromised computer in your environment or one of your servers are not behaving correctly, that you're not going to use those privileged accounts to go and figure out what's wrong, which is also something that we've seen before. The last three recommendations that we have, again, it falls to these are standard things that we want to make sure that people are using to prevent, because if a machine is compromised but still vulnerable, I mean, there's other means that the attacker can find to escalate those privileges and obfuscate. So you can secure all computers and servers, but obviously if they're unpatched, I mean, they're not going to be directly related to credential theft and reuse, but there's a risk, an added risk that can be facilitated to use those. Same applies to securing domain controllers, and removing LM hashes have been a topic for discussion as well, because we can remove LM hashes using group policy from the Active Directory, and we can remove LM hashes from the local SAM database. But in the LSAS process memory, there will still be LM hashes available, and they can be dumped with those tools that Mark presented. So at the end of the day, they do, by limiting them from being stored in the DA, and you prevent a partial a level of attack that can be done. There are some mitigations that we came across through the work that we're doing, investigating that some of them have been previously suggested as mitigations for credential theft and reuse. So we've created this section more to address these. We've seen them in papers, and we've seen them in a number of places. Obviously, as Mark just showed us on the demo, you can use Kerberos. So disabling an anti-LM as a protocol does not really prevent other forms of credential theft and reuse. And we just looked at Kerberos, but there's a number of others that are available to an attacker. Plain text passwords, like I pointed out, can be harvested from memory. And these tools support these mechanisms. So as a mitigation, disabling an NTLM is not something that we're pushing forward. But that does not mean that this list are things that we're not recommending. We're just stating that these things do not address past the hash and credential theft and reuse. But we want to encourage people to move to Kerberos. It's a more secure protocol. There's other added benefits of doing that. Perceived effort to do that is high because we have a lot of app compat, and we still got a little bit to go in terms of being able to deploy some of those. In terms of smart card and multi-factor authentication, again, there's the added benefit of not having the weaker password. But at the end of the day, even 2FA, you still have a password hash that is generated on your behalf and is stored there and used on behalf of that user to perform things like single sign-on and be able to access email and file share. So even though you're using two-factor authentication to authenticate to the machine initially, under the hood, the operating system is still using a single hash that is created and used for authentication. And at last on this section, rebooting and servers and workstations will clear out credentials that are stored in memory, and they will start fresh. But they do absolutely nothing if the machine is already compromised. I mean, it's a good way maybe to clear the credentials that are stored, but at the end of the day, if the machine is compromised and you authenticate to it, or rebooting a machine that's been already compromised is also not going to do anything. We can store those hashes and reuse them regardless if the machine is compromised already. Jump servers has come up a number of times as a mitigation, and while it does add security utility in architecture, you can allow isolated networks. There's a number of things that jump servers may facilitate, but in terms of security measure, it doesn't really add a lot of value for unless the environment is already secured. And we even heard that some pen testers love jump servers because they have obviously a lot of administrative credentials. So if they get popped, which they're usually poorly secured, from what we've seen, it's usually on the scenarios that we've looked at more of an added risk. And if jump servers actually provide as a mitigation, the mitigation is actually the server isolation or the hard machine that's been used to access, or the close life cycle of those credentials that are used, more of a combination of things than the jump servers themselves. So is the problem solved? We have these initial steps. We have a number of recommendations that we made. Like I said, these are initial steps. The problem is not solved. We have a work group here for the Microsoft employees that are attending the conference that they have interest on this. Look up the DL, get involved. There is a number of people that have already expressed their interest to work on this, and we as a group, I mean, there is members from various teams within Microsoft that we looked at this. So even though these mitigations, like I said, they're initial and they're simple, there's a number of people that has contributed and evaluated. So this is not my work. I'm presenting on the behalf of our work group. There's a number of people that have been involved on this as a work group, and this is the white paper that we came up with. Oh, I don't know if you guys can see the link, but you can click on it afterwards. And like I said, our work group will continue. We'll be looking at a number of other things. Mark already presented on Pass the Hash on Wednesday and talk about some of those things. So there will be next steps. This is basically your initial response. This is what you can do now with what we have. Practical, effective, simple, and then we can look at things that are more complicated.
Yeah, and some of the things that we've been looking at to help companies defend themselves against Pass the Hash are let them focus on specific accounts and also specific servers, and able to, for example, disable NTLM for specific accounts rather than all accounts. Right now it's kind of a hammer that companies just can't afford the risk of, but if there's a particularly high privileged account that doesn't require any NTLM authentication, just can rely on Kerberos, then at least you can get rid of the common attack, which is past the NTLM hash. And then we're also looking at even ways that we can modify the Kerberos protocol to really provide single sign-on experiences and also bind tickets to particular systems so that they can't be walked across the network either. Longer term work, so we're definitely multiple years kind of effort that we're looking at.